Bismillahirrahmanirrahim. I'm going to repeat the Thevenin theorem and then we will go for the problems. Then it would be easy to understand. The Thevenin theorem, how we can define this. Thevenin theorem, any two-terminal DC network can be replaced by an equivalent circuit consisting solely of a voltage source and a series resistor. So, for example, this is a network, we can replace it by such a network which would be having just a voltage source and a series circuit. That voltage source will call the ETH and that resistance is the RTH, which is the Thevenin equivalent resistance and the Thevenin equivalent voltage. The resultant network would look like this. Now, Thevenin is saying that if you replace this circuit by this circuit, it will not affect the output characteristic of the network. That is, now if you again attach the external part of the network with this small network, then the value of current and voltage and resistance will remain from between these two terminals. So that is what? That is the Thevenin equivalent network or the Thevenin theorem. Now, how many steps we can use to do this, to convert any network into Thevenin equivalent network? We can use 5 steps to replace a network into Thevenin equivalent network. Step number 1, remove the external part of the circuit. Step number 2, name the two terminals S and B. Step number 3, calculate the resistance between A and B such that if there is any voltage source, replace it by short circuit, and if there is any current source, replace it by open circuit. And then calculate the resistance between the two terminals, which is called the RTH. Step number 4, place the voltage and current sources on its original places, and then calculate the voltage between the two terminals, that is between A and B. In this network, when I place the voltage source on its original position, then the voltage from A to B is just appearing in front of the R2. So what we need to do is to calculate the voltage in R2, which is called ETH. So for such a network, we can use the voltage divider rule to calculate this, and you will use any convenient method for any situation. So now you calculate the voltage over here. So you find out the ETH value. In previous step, you calculated the RTH value. Step number 5 is the concluding step that place these two components, that is the ETH and RTH, in series to each other, and by this way you can replace that complex network into the simplest network. And if there is any external component, you can place on its original position. So these are the 5 steps of the network, 5 procedural steps in which you can convert any network into Thevenin equivalent network. And for this, a problem was given in which you need to calculate the current in the external resistance, that is in the RL. If the RL value is 2 ohm and 10 ohm and 100 ohm, I just explained their calculation to you. You can do the same thing by considering your previous procedures, your conventional steps. So if you are having such a network, find out without converting it into Thevenin network, find the current value in RL if it is 2 ohm, if it is 10 ohm, and if it is 100 ohm. And then you see that those current values would be same to that of these values which we calculated with the help of the Thevenin equivalent circuit are changed. So the theorem is saying that these values should remain same. Is there any question?
No, sir.
Okay, good. So now we will go for solving problems. And the first example which is given is what they are saying: find the Thevenin equivalent circuit for the network in the shaded area of the figure. So this is a network and this is the shaded area of the figure. And what you need to find the Thevenin equivalent circuit of this. Definitely you will make Thevenin equivalent network and then you will write the value of ETH and RTH. So what was our first step? To remove the external part. Number two, to name the two terminals. So we removed the RL, which was the external part, and named the two terminals as AND. So two steps we did. Step number 3, calculate the resistance between A and B such that if there is any current source, replace it by open circuit, and if there is any voltage source, replace it by short circuit. So here we have the current source, we replace it by open circuit. So if we replace this current source by open circuit, then what we do? Then we calculate the resistance from A to B, which is called the RTH. So now from A to B are two resistors which are in series because we replace this source by open circuit. So this is just 4 plus 2 is equal to what? 4 plus 2 is equal to 6 ohm. So 6 ohm is the RTH. Step number 4, place the sources on its original position and then calculate the voltage from A to B. In this problem, what is given over here? A current source is given. So if you place it on its original position, then the current will flow in this way. So you would be wondering that why the current would not be flowing this way, because from here to here we have open circuit because we removed the external part of the circuit. So if you remove the external part of the circuit, then zero current will flow in this way. So if the current is zero, then definitely voltage would be also be zero. So now the voltage from this point to this point would be what? The voltage over here plus the voltage over here, but here it is 0 volts. So it would be just the value of voltage in the R1. Why not in the R2? Because the voltage in R2 would be 0. So the situation is very easy. Here you will find voltage with the help of Ohm's law, that is V is equal to IR. The I value is this one. All the current is flowing in this way, and the R value is given. So V is equal to IR is equal to what? It is equal to ETH. And you solve it, and you get 48 volt because the R value is 4 ohm and the I value is 12 ampere, and none of the current is flowing this way because this is open circuit. So you get the value of ETH, that is the voltage from A to B. The final step, that is step number 5, is to make the Thevenin network, that is place ETH over here and place the RTH in series of this. We know the ETH value is 48 volt and the RTH value is 6 ohm. So we just place it in the manner as the theorem is saying, and then place the external part on its original position. So that's all for this problem. Is there any question? कोई चीज जो समझ में नहीं आ रहा हो?
सर आरटीएच सीरीज में कैसे किया आपने?